Please start, sir. Continue.
So, thank you very much, and hope this is audible for everyone. And This is a very interesting topic, and this is very near to me for the company as an industry and entrepreneur. So, I like to share some of these my insights and on academic research, innovation, science-based business, and entrepreneurship. I just main purpose of this lecture is to motivate students who come into the science-based business and entrepreneurship. So first thing is there is a two paradigms: academy and industry, science and business. How those are distinguished? So if you see science versus business, academy versus industry, there is a lot of contrast here. Science holds methodology sacred, whereas business focus on results, because if someone discovers some kind of invention, they think that that's more sacred and that's more novel, everything. But the business looks different, and those are more focused on results. Science values openness and sharing, whereas business generally demands secrecy and proprietary, and that's why all the IP or intellectual property rights, all this comes into the business. But again, there is a big contrast. That's when finally we want to come into that gap. We need to fill it very much for the academy and industry. See, generally academic research takes long lead times, whereas tight timelines for the industry projects. So the industry is very much time-bound projects. Industry persons focus on work on specific agendas, whereas academicians pursue on their own curiosity, interest-driven.
Sir, excuse me, sir. Sorry.
Yes.
Sorry. Presentation is not shared, sir.
Huh?
Full size, screen size, sir. Can you
This
make
is a full size.
Right, sir. Right then. Sorry.
Is
full
it
screen option, sir? Under.
This is a full screen now. Now?
Yes, sir.
Can I go ahead? Are you able to see full screen and audible?
Please, please go ahead.
Okay, thank you. So this is how the industry person focus on work on specific agendas. Academicians pursue on their own curiosity and interest driven, and no specific agenda. I mean, they have their own focused projects like that. But academic research and training is mostly funded from the government sources, and whereas industry expenditure is expected to produce income. So this is a kind of big contrast. That's how the science, business, and academic interest. But all that it is leading to the creativity. So creativity is a novel approach to the solution. That creativity comes in different ways. The one can be compassionate to the society, and they can be more creative to the certain solving the problem. And intuition also. Sometimes the people will get intuition of that particular solution, and the strength and will and joy of how we joyful to be a creative person. So whereas the science-based business is the creativity is the first thing, and then comes to the innovation, intellectual property, business models, marketing, and monetization. These are the five ones very much you have to remember. Creativity is the first one, then innovation, IP, business models. So imagination is more important than knowledge. One can be more knowledgeable, but the imagination, the vision is more important. So that's where all the creativity, all new business products will come into the society. So next is the innovation strategy. Is the science concept is investable, but again, deep understanding and expertise in that particular area is more important, and that's how one can be more successful. And then the second one is networking skills and vast network. That networking, people connections is more important in the where this work to be done, how it can be taken to the next level. That's all it came into the networking skills. Then commitment. So we have to commit skin in the game. So that's more important when you have to commit to develop some particular product or particular invention or innovation. That's more important. So again, invention, there is a big difference, invention and innovation. Invention is just, I mean, you discover something, but innovation is how it is taking it to the market or it lead into the next level. So invention is not an innovation. So that's what, I mean, innovation management is again the paradigm of internal innovation. That means one, I mean, in-house, if you are developing some particular product development or research, you have to go through stage gate process, but you have to evaluate how those, what are the hurdles and what are the phases, I mean, you have to face that stage gate process where you will review. And again, the executives or management should embrace, I mean, anything invented anywhere. That means they have to have a kind of option of anything invented anywhere kind of thing. And breaking down silos, I mean, you have to break down the silos to compete in this innovation world. Include the barriers of external partnerships and collaboration. That's what, I mean, the anything invented anywhere kind of thing. So the internal versus open innovation. So everything, I mean, the idea is idea or creativity or whatever, I mean, that particular idea is important, and then that idea to be validated. And this third one is a proof of concept, prototype and production. That's how it lead into the market. I mean, again, you see there is a closed innovation model where it is developed, R&D is a full in-house, and then there is a the open innovation system. It can come from internal source, internal, I mean, R&D, or outside the external R&D, where it is taking the R&D and then it goes to the market. So this, the internal and open innovation, inside and outside, present scenario is presently it is like 80:20. I mean, every company wants to be develop their own in-house like that, but the future is going to be the other way. It is quite opposite. It can be developed anywhere and taken into the I mean, internal R&D and developed further into the product. So that's what, I mean, internal versus open innovation, where one should be very open to where the technology anywhere invented any place. So then the intellectual property innovation is one side. I mean, I will take in these all, I mean, briefly these things, I take it to the next level. I mean, how the examples are going to be each one innovation, then how it will be developed, the IP part. So the intellectual property portfolio should be one. Finally, look at any company will be a defensive. I mean, how defensive to the competition, and then cost control and the profit center, and then integration. They can be integrated to horizontal or vertical, and then visionary products. So they can be visionary, but the vision without execution is hallucination. That's what Thomas Edison. So we have to execute the vision to the next level, or that's what the invention taking it to the next level, to the innovation. So the intellectual property strategy should be, it should be a business strategy and patent strategy. That's the corporate strategy and invention strategy areas. But the R&D, these all business and patent strategy to connect to the technology R&D. That's where you develop the intellectual asset creation. So the IP assets. This is the valuable asset than any physical assets in the company. So the IP is such a strong to have any academic institution or any industry related to that. Next one is, once you have a IP, what you will do? You can get a patent or trademark or copyright and trade secret, and for depends on the country, you can have a different kind of intellectual property rights, where this is your business IP. Now you can exercise that particular IP to market power, or you can sell that IP to some other companies, license, collaborate, and sometimes you can donate to the institutions of IP so that you can get the tax break and achieve other objectives. So this is how you can manage IP and you can lead some kind of revenue generation by looking the more into innovation. Then the business models is in business is mostly the four pillars: the capital, people, markets, and ideas. So one, if you discovered something, you discovered, and then you can go. Most of the academic institutions directly they are going to the publication. So, but it has to go a patent. You can patent it, and then further, you can go for publication that leads to the product market testing, and then it comes to the a startup stage. Where you proved. Like I already said, idea, proof of concept, and more production. So this is the stage you will begin. A startup company. So how the startup company is, you are here, and then technology transfer, and you are looking the more business plan, or you are looking for the capital from the investors, and then that's how you deliver into the market. And see, this is a very dynamic one. It can change: capital first, people second, or people first, capital second, ideas is first, like that. It is no priority here, but all are very dynamic in this these four pillars: people, capital, ideas, and market. So that's the business model. And if you want to start up a company, again, the four pillars always, these are all top five lessons. Be prepared for the scary and exciting time of your professional life, because this is not like a 5-day week or 6-day week. It is a kind of 24/7. So only work with people that have high professional and personal credentials. That's their, how to deal with the people's management. And then you are always fundraising mode, and you always need manage your cash flow. This is a capital related one. Focus on execution towards realistic milestones, and focus on your customer, client, and end user, the market. So when you have idea, all it will circle around the four pillars: the people, capital, market, and ideas. Then next is launching a company. That you can have set the 4 or 5 milestones in the first year. Get your core team of employees and advisors on the board. Secure the rights on your technology asset. That means you are very much safeguarding your technology and asset, the IP part, and understand the pros and cons of your technology, how it fits into your customer needs. And then most important is this is a networking. Draft a practice your 30-second, 5-minute, 30-minute business pitch. So wherever you meet people, how you can deliver, how can you pitch your business, what product, what innovation you are doing. Then if you are not able to do first 1 to 4, then stop launching a company, because this is no use. You need to have this kind of 4 milestones to launch a company. So then second is, you want to be entrepreneur. What is, get ready for the roller coaster journey, because here it's not like a kind of very smooth sailing journey, and it can be go up and down. So you have to be more balanced in your life to lead into be entrepreneur. Apply intuition and decision making, and drive projects clearly defined decisive points. Learn regularly. It's not like one time you studied and then that's not enough it. So you have to constantly learn and confident on your strengths. Have a plan to succeed, or fail as early as possible so that you can learn good lessons. So either it can be successful or failure, you are going to be learning the lessons. Enjoy the entrepreneur role, because you are entrepreneur, you have a free time, you are a freelancer, you can be, you can enjoy the business. Do not allow the naysayers, because people will say no for everything or some things. So don't allow that kind of naysayers, but you just go with intuition. What your hello.
What is the issue?
Internet issues, sir. From sir's side.
Okay.
Yeah. Now can you share your PPT, sir?
I will see that. I mean, here
Yeah, can
I'm
show your
not able to
PPT.
see the presentation. F5 function 5.
Yeah, first you open the PPT, sir. Okay, first you upload the PPT. So don't go for the screen share. You can go to the arrow mark, left side, top.
If there is any issue, I think we also can operate it, sir, from our end.
Yeah. Can you upload your PPT, sir? Then
Here I'm not able to see that completely. I mean, power is back, but from my phone I can work on. I think maybe.
okay. Can you share your PPT so that we'll share from our
Yeah,
end?
that's what I'm trying to do here.
Just you can
Maybe
check your email, sir, somewhere like this.
actually it's not doing anything.
All these are inevitable, sir. No issue, sir. Please take your time.
I'm not able to upload the PPT.
So can you send your PPT to my email ID? So that we will share from our end.
to continue my, presentation, it is difficult from you sharing from there here.
No, you can see that. You can see our.
Or you can speak, sir, without PPT also, no issues. If you feel you are comfortable.
PPT is required. Select an all. Where is this? Oh. PPT here out from the phone where it I can share. I can.
So we received another account. You are logged in from other account.
So here I can share.
Sir, you can share your screen at least, otherwise.
Prasad, so whether I can share in the phone also this?
Yeah, you can share your screen, sir, from the phone or tab. Or otherwise, you can continue, sir, without PPT, no problem. Yeah.
Okay, you are with the slide 5, right? Okay. So can I continue, Prasad?
Yes, sir, you can continue.
So as I was telling, innovation strategy, I mean, science-based business is innovation, and then intellectual property, business models, and marketing and monetization. Uh, Innovation strategy is deep understanding and expertise, networking skills, commitment. Those are the key strategy for the innovation. Then it comes to the open innovation, and then your close internal innovation. So those are the two models. I mean, mostly you can embrace anything invented anywhere model. So, and then the the ratio, the present scenario, is inside innovation. Internal innovation is mostly the 80%, and then comes to 20%. And then the future scenario is going to be more open innovation. So anywhere invented in any place. That's more one. So the intellectual property is going to be a defensive approach and cost control, profit center integration. When you can integrate into your product line, and then comes to the one visionary. The visionary is going to be vision without execution is hallucination. That's what Thomas Edison mentioned. So the intellectual property strategy is going to be corporate strategy areas, and then invention strategy areas, and then product strategy areas. These three lines, you can go and develop new products and develop assets, IP assets for the company. Then any intellectual property management, where the patents and trademark, copyright, trade secret, and your business, IP business, and then your options is how to exercise that IP into the market power. You can sell the IP to different companies, license, collaborate, donate, achieve other objectives with IP management. Then your business models is four pillars: capital, people, market, and ideas. One, I mean, mostly once you discover something, and most of the academicians, they prefer to go like a publication. But industry first, they look at the patent. That's what we need to change. Academic research innovation is, once you have discovered, you just first try to go whether it can be patentable, and then further it can be proceed to the publication, and then take to the product, and then market research, market testing, and the proof of concept, partner, and startup. So your startup is kind of, again, more key is the people, ideas, capital, and market. So these four areas, four pillars for the company, you have a right team to come up with the company, and the right idea, capital is important, and market is also important. So the four pillars. So it is a very dynamic, these four areas. It is going to be priority changes based on the Are you able to see the slides now?
Yes, sir, we are able to see. Can go over to F5, sir, now, option F5.
Function 5. Yes, I pressed function 5.
You can continue, sir, now. No problem. You can continue. Now we are at the slide number 13, sir.
So anyone, I mean, these are the lessons to start up a company. I just go, there are so many lessons to learn, but top 5 is, again, it comes with the people, capital, market, and idea. So, but mostly be prepared for the most scary and exciting time of your professional life. Only work with people that have highly professional and personal credentials. So you are dealing with very high professionals in the science-based business. So you are not dealing with the kind of low-tech people. So it is so very important how you have to deal with the high professionals. And you're always in fundraising mode, and you always need to manage your cash flow. So focus on execution of towards realistic milestones. Focus on your customer, client, and end user. This is a market, and this is the main thing comes into that. So then, launching a company is the first the 4 or 5 milestones in the first year is again you need right people, right team, employees, and advisors on the board. Secure the rights on your technology, that is the IP or the protection of your technology, and developing asset on related to that, and then understand pros and cons of your technology and how it fits into your customer needs. So you are going to do some market research and how, and the most important is draft and practice your business pitch for 30 seconds, 5 minutes, and 30 minutes. That's where your network skills important to connect right people and right fundraising. If you are not able to do your above 4, then stop launching a company. So because these are 4 key to launch a company. Then you want to be entrepreneur, get ready for the roller coasters. I said it's it's a very kind of roller coaster kind of journey of life, and apply intuition in decision making, and learn regularly, confident on your strengths, have a plan to succeed or fail as early as possible, so that you learn good lessons to move on, and enjoy the entrepreneur role and joy of business. And do not allow naysayers. If someone is saying no, uh, don't allow that kind of discussions. Ignore voice of judgment. So always negativity or voice of judgment, ignore that, and so that you will be more successful entrepreneur. Building a company, what to consider: you need to own something that can be financed, and consider all potential pathways for raising the capital, angels, VCs, grants, and foundations, etc. Build a network and keep in contact. That's where the people do not fear for the dilution. So that is binary business. Practice your pitch and keep it fresh. Your organization, product innovation. So the company, in the beginning, the success and sustainability of the company comes. You have very early struggle, and then you are somewhat successful. You will be having a fun. Then this is all whitewater. Your company is growing. There are operations and sales, all kinds of different departments, and you will see the predictable success. This is where the all it's a dynamic, this role. But anyone, if are not lost innovation or any other reasons, then you are going to be having a treadmill kind of thing. And the key people left the company, then big rat, and then finally you have to exit the company. So that's what the always all times it has to be early struggle, fun, and whitewater and predictable success. So your growth has to be like upwards, not the downward like a treadmill and big rat and death rat kind of thing. So the monetization is kind of marketing and monetization, the business without borders. So this is a book I just referring. You see, so you can have no borders for the business. So you can it's a global, and you can monetize and market the products. How the funding, especially the funding sources in India for especially the academic research innovation. There are so many agencies, Department of Science and Technology, Biotechnology, DBT, and so many other. they can find, this is a very old slide, 2018, and it might have gone up these areas. So all, I mean, you can tap into that kind of funding sources to go into the academic research innovation, and that lead into next science-based business. How one has to, I mean, these are some of the examples I just want to show you, that one can be the academicians, I mean, they can have a kind of different concepts, different ideas. See, this is the one of the DNA encoded chemical libraries. This is in Scripps. Richard Lerner and Sidney Brenner is a Nobel laureate. They are thinking that how to combine chemical and biochemical together, and that's how the chemical is a chemical, biomolecular. If you have like a DNA, it can be replicated. So, and DNA has a signature kind of, I mean, a sequence that can be used as a barcode, and they come up with a concept, and now you see a discovery. They discovered this particular DNA encoded chemical library concept, and they first patented and the publication. And here you see, that's how, I mean, academicians to go towards, I mean, like a kind of, before going publication, they think that what is the potential to patent it. Now that became a revolution technology, and for drug discovery, a vast number of compounds screened at a fraction of price. So if one wants to make a small molecule, synthesize, and one can make maybe in a month maybe 10,000 compounds or 1,000 compounds. But with this technology, you can make millions of compounds. And how it works? You can have a kind of DNA tag building block. You can couple, I mean, various different DNA tags. You can have, I mean, suppose 10,000 molecules, two building blocks. It can go a millions of compounds, and that chemical library you can screen to the target proteins, and then you can be replicated and then sequence what particular building block is actually bound to the target. You don't, I mean, here I'm not emphasizing more on the details of the technology, but you see the business how, and here another CNS target, how they made this technology, 117 million compounds, this library, and then from that you can have a lead compound, then optimize. This is the one, it is going into the clinical trials, particular target. So all is actually, are you seeing the slides now?
Yeah, you can see. We are at the 27 slide. Sorry, 24.
Okay. 25, the 25th slide. Are you able to see?
24, sir.
Hello.
Hello.
Yes.
Yeah, you can proceed, sir, without PPT.
Are you seeing the slide, Prasad? Hello.
Slide number 19, sir.
Hello.
Slide number 19.
Mm.
Now it's, yeah.
You didn't see these slides?
Yeah, we are able to see. Yeah.
Did you see this slide before?
No, sir. No, you can start from here. You can continue from here.
Okay.
Next slide. Yeah.
So these are the different funding agencies in India. As you know, you can have various funding for the academic research innovation, and how the innovation starts in the academic setting, and that lead into the next level. So this is one of the very interesting example where the Richard Lerner Scripps professor, and Sidney Brenner is a Nobel laureate. He's also a Scripps Research Institute professor. Both are thinking that how to combine chemical and biochemical, and they developed a technology called DNA encoded chemical libraries. And they discovered, and they went for the patent and then publication, and they discovered in 1992. You see this technology, how it took into the powerful revolutionary technology in the drug discovery. So, as you know, chemical is a chemical, biochemical is a DNA molecule which replicate, and that can be used as a barcode kind of thing. So, you see here, you can make a kind of libraries various with the DNA tags, and you can expose the DNA library with a target protein, and whatever is bound that can be replicated and then sequenced and identified particular small molecule, which one. So you can make millions of molecules by this technology, and now we can optimize, and this molecule is going into the clinical trial. So ultimately, the academic research, as you see, this technology is discovered in 1992. It took almost in even 2004. This is mostly the academic research, academic kind of effort. But later on, it took to the industry. Now, 2016, these technologies is very powerful. Most of the companies they use to make millions of molecules to go into that. So again, the nitric oxide is another, you see, before even 1980s, nitric oxide is a nitric oxide molecule, but this is a kind of a signaling molecule, and these scientists shared the Nobel Prize, Bob Oppenschgart and Louis Ignaro and Fred. They, and I have a chance, I mean, because I also worked in nitric oxide synthase enzyme, and this is a garden conference, Louis here and myself here. So, which we are very exciting times, this 1999, 2000 times, where we did a lot of research in the. What is this nitric oxide synthase? Is L-arginine converts citrulline and nitric oxide. There are three isoforms in the body, and one of them, this endothelial nitric oxide, which is actually maintains the blood pressure, the constriction, dilation, and then if it is excessive nitric oxide, that leads to the septic shock. So Alfred Nobel actually discovered dynamite from the nitroglycerin, and he also patented in 1863. And from his wealth and inventions, he created a Nobel Foundation. I mean, not he. I mean, later on, his wealth is created, and he died in 10th December 1906. I mean, his will is to offer the prizes for the greatest benefit of the mankind, only the five physics, chemistry, and physiology, and medicine, literature, and peace. And nitroglycerin is also used as a kind of NO donor and used as an angina. So this is the molecule, and this is the patent of nitroglycerin of Alfred Nobel. So this is the kind of nitric oxide is known for a long time, but and again, there are so many donor drugs, nitric oxide donor drugs. You study that, and now more recent ones is aspirin, also NO, non-steroidal anti-inflammatory drugs, even statin drugs also combined with nitric oxide. So this is a safe area where the nitric oxide and the killer zone, those are the donors. It can be used for the cancer therapy, and then excessive generation like a septic shock where it requires NOx inhibitors. And you see, this nitric oxide, it became much more popular in COVID-19 time. There are more than 20 clinical trials going on the COVID-19 inhaled nitric oxide. So it can be microcidal activity of the nitric oxide. And then there are one sanitizer, a Canadian company, where it developed a self-administered nitric oxide nasal spray, and it is a very powerful 1999.5 against different types of different variants of COVID, coronavirus. And this sanitize, I mean, this nozzle spray is now IND in the clinical trial and phase 2 trials. So there are so many other. This is another NO donor drug which is used in COVID times, where this is a much powerful. Usually, namoxia is a kind of from arginine to nitric oxide, whereas this one is directly the NO donor molecule to the nitric oxide. So here, when NOx is a kind of excessive generation, it leads to the various diseases, INOS related one, NOS related. So these are targets, drug targets. ENOS is the kind of it maintains the blood pressure, homeostasis of that. So I worked several of these NOS inhibitors, amino acid based, non-amino acid based. Here also you see we went first to the patent and then the publications. So there are so many amino acid based inhibitors. So that's how the one has to go with the patenting. If and then if not, there is no potential, then we can publish it later on. This is another Nobel Prize shared in the medicine for the anti-parasitic drugs. Bill Campbell, he isolated the ivermectin. Now ivermectin is very much popular in the COVID times also now. And Omar isolated this streptococcus, and two actually artemisinin they shared. And so here there is so much antibiotic drug candidates. See here, cephalosporins, beta-lactams, all, I mean, cyclines, penicillin. So this market is huge. So they are science-based business. So if anyone wants to invent and innovate particular drugs, it leads into the so much science-based business in the pharma. So this is is the growth of the market is growing, especially in the Asian countries, India and other countries. And then, but there is a kind of another alarming one is the resistance to the antibiotics. As you see, the penicillins discovered in before 1940s, but already resistance came in 50s. So all these cephalosporins, those all drugs is kind of now antibiotic resistance occurs. So this is a very challenging scenario, especially in 20th century. You are just taking a dark age where you are want some pill, but this is a golden era of antibiotics in 80s time. Now very few drugs are coming out into the market, but you see, it's a very challenging antibiotic resistance, and you go with so many, different vaccines, all the, phase, like that. So this is a quite alarming. In 2050, the antimicrobial resistance is projected to kill more people than cancer and diabetes, even combined to the COVID. So estimated 10 million deaths a year by 2050 at drug-resistant infections. So this is a quite alarming. One can see how much opportunities to develop such kind of antibiotics to overcome the resistance. As you see, if all the discoveries goes more, kind of small molecule and gene level, and once this discovery of the DNA of base pairing, how this technology taken, to Linus Pauling also worked in the DNA, and he coined sickle cell anemia is a molecular disease based on, a simple one base change, GAG to GTG, that change to glutamate to non-polar valine, and that becomes a circular, red blood cells, it becomes like a sickle cell. So sickle cell anemia and beta thalassemia is a very very much, especially African countries where the sickle cell anemia in India is a capital of thalassemia. 40 lakh carriers and 10,000 live births thalassemia every year. About 1 lakh thalassemia majors, they 50% of them will not survive beyond the age of 25. India spends around 15,000 crores of thalassemia treatment in each year. 90% of the patient's expense is out of pocket with no help from the government. The country's blood transfusion burden is 2 lakh units for every month, and 4 out of 10 thalassemia patients will not workforce, unemployed, underemployed. So how this, this thalassemia and all, see, this is a kind of sickle cell anemia is occurred in 1949, the invention of PCR. Now everybody knows PCR means. So PCR is a polymerase chain reaction. Campbell actually discovered 85. How it became this technology so powerful in the COVID times and other areas. We know before this how this technology is powerful, and that PCR is a kind of now used very much in the COVID times, where the PCR is only, very helpful. First 14 days of the infection, and then antigen antibody. So that's how the COVID testing is done. So then RNA is actually ribonuclease kind of. It's a catalyst kind of thing. And then you see all these discoveries, genetic code and protein synthesis, where Corona, Harbin Govind Corona, I actually discovered this code, and here this is ribosome is discovered, Winky and Thomas, and they also go into the how the ribosome RNA to make the synthesis, the protein synthesis of 16S and 60S kind of ribosome. So these preliminary technologies lead into the recombinant technology. That's how the Paul Berg shared the Nobel Prize in 1980 in chemistry, and this recombinant technology became a very vast area in the biotherapeutics. You can make recombinant proteins, monoclonals, vaccines, and antisense others. And Friedrich Sanger is a two-time Nobel laureate. He also discovered the insulin, and then He also shared the Nobel Prize with Paul Berg with the sequence of the base sequence of the nucleic acids. So the RNA interference technology is another one. It came into the 1988, and you can, silence the particular mRNA, and this became, you see, 1988 is the first time they discovered, but first RNA based drug approved in 2018. So it took two decades unfactorize the drug which came into the RNA interference technology for the amyloidase. So transdirectin is the target protein. How this transdirectin mutations can be silenced and with the RNA interference technology. Then 2020 Nobel Prize in Chemistry is a kind of CRISPR gene editing tool and the genetic scissors and Jennifer Doda. Actually, this is a very nice book, The Code Breaker. One can read and you can see the, how the journey of the Nobel Prize. This is the very shortest time. This they discovered 2012 and Nobel Prize is given within 80 years. This became a powerful tool, and you see how the patenting is going on in the CRISPR technology. As you, it's exponential patenting compared to the all other different gene editing technology like zinc finger nuclease, talents, RNA interference, and CRISPR technologies. This CRISPR technology can now able to solve, it can able to, rectify the mutations in the beta thalassemia. So this is one of the technology used. One can recover beta thalassemia with this, but still there's a long way to go to come into the market, that particular one. And the CRISPR technology is used in the SARS-CoV detection where loop amplified polymerase LAMP based. So WHO and CDC they showed what all the N gene, E gene, and they can see the kind of lateral flow device of the COVID infections. And this is another RPA technology, recombinant polymerase. This is not required the PCR or thermocyclizer. This is all based enzymes based and with CRISPR, and you can see simple lateral device kind of CRISPR technology. So, and this is another Nobel Prize here. Transposons. We might have studied in the molecular biology how the jumping genes and especially when it is the corn, maize varieties, how these colored maize varieties are, these are all jumping genes, and this is again the technology how it translate into the innovation. See here, this girl has a Batten disease where one of the innovations, and that becomes like a science-based business. So all this drug discovery approach is a kind of known and structural based drug discovery and DACL, DNA encoded chemical library like here. So this is all a focus of the drug discovery. But you see here, we are going in a gene level gene editing technologies. RNA you can upregulate and downregulate, and then protein based. So you can most of the all the medicinal chemistry or enzymology or agonism and antagonism. But there is a new technology called protein degradation. So once protein is formed, you can degrade that protein by, here again a Nobel Prize is given to discover ubiquitin mediated protein degradation. So this discovery, so you mostly whenever the protein is, it's a native protein, once it is folded, the E3 ligase will come into that ubiquitinated, and that lead into the ribosome, proteasome, where it can be degraded into the, and then it chops off and then makes a, like amino acids. So here they want to use E3 ligase as a one enzyme, and we can design a molecule which binds to the E3 ligase and then target protein. That's, see, this is called PROTAC. So the PROTAC molecules which brings targeted to that particular target protein and then brings the E3 ligase. So you are going to ubiquinate that particular protein and degrade. So you are agonism or antagonism kind of thing, and then degradation also together in same time. So this is a very powerful. See, all these discoveries happen in academic institutions, and where it leads to the different kind of innovation into the market. So, as you see, India is publishing very much innovating, but it is kind of this is a statistics which is a science and engineering journal articles in all fields. You take it to 2004 to 2014, we are very close to Germany and Japan, where we are very much publishing the papers. So, if you see patenting wise, role of India in science, impact of innovative science in drug discovery. When you see the patenting global versus India, we are very much low here, where not even seen in the graph. So you see number one in patenting is Japan, next to US, then China. So we are in 19th place, where here the point, not even 0.5% of the patents. So this is one of the Hindu newspaper where it published, here India is patently inadequate. So again, if you take state-wise patents 2015 to 2018, again you see here the PCT total worldwide, there are thousands, 50,000 or 60,000, close to that, and India is patenting only 2,000 patents in that year. And mostly those patents also go into the chemistry, pharmaceuticals, and other fields like that. So this is where, either you innovate or perish, or innovation is critical for the future medicine and needed good science. Again, for good science to be nurtured and investments in the research to be profitable, patents are essential. So that's what Dr. Anjireddy, this is the book one can read and see that how important the patenting and the investment comes of that. So this is where the academia industry, the bridging the gap. So you are giving most good education, and that needs to translate into talent. And same way, the research has to translate into innovation. That's where the industry and academy, this synergy should come. This is where big gap is seeing in India, especially, and we have to identify and bridge the gap between the university and academia and industry. So, to promote that kind of interface, promoting innovation as a national and state agenda, a new drug discovery biotherapeutic development will be the culture of every pharma and biotech company. Academic institutions should collaborate with the industry, vice versa, for the new drug discovery and other innovative projects. Patience and perseverance are key in the innovation. So it's not like overnight all these things will happen. So it is a more patience is required, and commitment and accountability leads to the better results. So this is all, a good, message for the synergy, academy and industry interface, and then this is where the innovation society and prosperity. So indeed, innovation is the key, and now everyone's job. So it is quite interlinked between politics, media, and the industry and science. So the academy is a science here. It has to translate into, this legislation should become, and funding, all other things will lead to the science. So the society wheel has to run with a kind of media. Gives the nice stories about that particular how how popular, how attention it came into the COVID times, the science. So that's what the most important. This wheel should go innovation, society, and prosperity. So thank you, and here lot of different books to read, academic entrepreneurship, all these things. So thank you your attention. Sorry for all these different troubles we went through with power failure and connection issues, other things.
Thank you, sir. If you have any questions, please feel free to ask. I request students to raise any questions. Sir, what do you suggest to students to become specialized in lead optimization techniques, sir?
Lead optimization will come into later stage. First, you have to have a hit and a lead compound. So, like quinine drugs. So, especially in antimicrobial, quinine is a kind of lead compound that became so many different molecules to lead optimization. So, lead optimization, so many different SAR techniques, QSAR, docking studies, all these come into that, and that lead into the lead optimization. So that is the next stage of getting into the level of the optimization.
Thank you, sir.
Yeah. Thank you, sir. Thank you very much. And you have taken wonderful examples of the potential of the academic research. And you have given very good examples and Nobel laureates and their investigations and the impact on the science and technology and its applications also. Thank you, sir. Thank you very much for accepting our invitation on the National Pharmacist Day. And thank you once again. Good day.
Thank you. Thank you very much. Thank you for the opportunity.